Algebra 2, Polynomial Functions. Characteristics of polynomial functions. This video is for the student who finish Algebra 1. Algebra 2 is the continuation of Algebra in high school. Polynomial. What is polynomial? We have to know what the polynomial is first. So far, we learned binomial means x square function, and the characteristic x square. The polynomial means x to the nth. Okay, so y equals, we have a coefficient an, the x to the nth plus another coefficient, and x to the n minus 1 plus so and so to the last constant coefficient a0. Example is y equal to x to the fourth minus 4x to the third minus 3x to the second plus 3. Okay, this particular function, if you draw on x, y coordinate, you will notice this point. This function has a 2 minimum point. Can you tell where the minimum point is? Yeah, it's labeled here, right? And there is a one maximum point where? Well, this is maximum point, but it's called local max. Means it's maximum around here. But obviously, this value is smaller than those value. So there is one local max and 2 local minimum. Okay, in this function, this is the absolute minimum, right? Because no value is below this. That means y is always larger than this value. Okay, so that's a terminology you have to get used to. And this function increases as x value increases, right? This way. And this function increases as x value decreases. So x value goes there, y increase again. Okay. There are two intersections on x-axis. Here, R1, R1. So what are those R's? Roots, right? So when y is 0, when you set y is 0, you solve this equation, determine the unknown value of x and the multiple values possible. From this graph, you can tell the R1 is possible, R2 is possible. Intercept of x, there are two intercept, right? So two roots in this equation. There is one intersection on y, which is here. That means when x is 0, here, the y value is determined. The x is 0. This is all 0. The y is 3. So it's happened to be local max. So now you see polynomial function has multiple roots, multiple local min, multiple local max sometimes, depend on equation. And when x goes very large, it may go positive or negative, we don't know. The x goes negative, very large, it's not large, small, right? Very large negative number, then y goes positive in this case, but it could go negative too. So that's the characteristic you have to understand for the equation. The why we talk about this polynomial function. First of all, what's poly means multiple nomial. So you have a multiple terms in the equation function, right? That's why polynomial. So this polynomial function, the first things to do is to understand the characteristics. Okay? So here you go. First of all, polynomial function characteristic. Do you remember the quadratic equation? Okay. This equation, this function, when y is 0, we can factor it, so we know there is a single root. So it's look like this, and it's touch and go, right? So this single root, double root, is characterized as touch and go type of contact with x. Okay, so we have to know type of root when you factor it, and you have this type of, the square is double, x minus x1, third is a triple, the fourth is double roots, right? I mean, it's twice doubled. So those are touch and go type of the root. So first observation, we can say, here you go, this polynomial, you can factor it into x minus 3 to the second. Okay, so there is triple root here, and triple root looks a little bit different. It's touch and go, but instead of touch go up, touch and go down, so touch and sink type of root. Okay, so it seems to be depend on n, and if n is even, it's going to be touch and go up again, or it could be touch and go down, right? Depend on the sign here. Okay, but when this n is odd number, it seems to be like this, or other way around. So it's going to be touch and rise, or touch and sink. Okay, so this is odd, and root like this, touch and go, is n is even. Okay, so this is the first observation. We can deduce that the power makes this difference. Even numbers will curve and stay on the one side, stay on the one side, stay on this side, or stay on one side. Okay, and while odd number will make the curve crossover. It's crossover. Okay, so you see that's the first characteristic about the root. You look at the root, it's a double or triple, depend on type of root, you know how the function curve goes. Okay, next characteristic. Okay, we take the example of this guy, this polynomial, x to the third, and another x to the third. Okay, so this one has a root 4 and negative 2. 4 and negative 2. So the first one must be this guy, right? And the second one is 1, negative 1, negative 3. So this guy, right? It's intersect 3 locations. So when you factor the polynomial, That's why we learned how to do factoring in the previous video. The factor tells you that you will be 3 distinct roots. That means you are crossing the x-axis 3 times, like this guy, going up, going down, and going up again. It's crossing the x-axis 3 times. Okay? On the other hand, when you have one single root and one double root, one single root is crossing this way, and double root is touch and go, so it's going to be like that. Okay? So it's very important. By factoring, you can kind of draw overall curve of polynomial, right? So when somebody give you polynomial, okay, say here's a polynomial, draw how it look like. First thing to do is check root and the type of root. Okay, then follow the rules so far we talk about. Okay, so that's gonna be the way you can kind of draw quickly the polynomial function. Find the roots. How do you find the roots? Factor it. If you cannot factor it, what do you do? We talk about that later. Okay, so polynomial function characteristic. Now in this example, y equal x to the 4th minus the remaining term is happen to be like that, 2 double roots. Okay, so curve come down and touch and go and touch and go and come up. Again, double root shows up exactly the same way we had observed. Even number power will bring both ends go up. So another thing you can tell is if highest n, x to the n is even, then when x is large it goes up, x is very large and negative still go up. Make sense? Because if it's even, like second, negative number is going to turn into positive number. And when x is large, this guy is large, then this guy dominate characteristic. Remaining is going to be minor row. This guy dominate when x is very large, or negative x value is very large. So this is dominant. At x is very large, or x is very large negative. Okay, so we can tell by looking at this n, you know which way the curve goes, up or down. And if there is a negative sign here, then you know it's look like this. You have to flip entire function down, right? Because it's negative. Okay, so we found out more characteristic of polynomial. Now we summarize here. Minimax of polynomial function. We have a local max, local mini, local max, local mini, and global max. Absolute max or global max. In this case, okay, there are global minimax and local minimax. And number of minimax is always smaller than the number of roots, right? Because number of roots, when you have one, it could be touch and go or crossover, right? Double roots, you have 2 roots, same value. So what we can say is the number of minimax is always smaller than the number of roots. Is that right? Here we count the double root as 2 and triple root as 3. So the root, even double or triple, we count 2 or 3. Then say if you have double roots like this, we have local mini and local max. Number of mini and max is 3 for x fourths, but the root is 4. Minimax is 3, right? So that's what it's saying. Okay, so analyzing polynomial function. When we have this type, we can have polynomial factored into this form. Then it show up every root. Every root is touching x-axis, right? But if we cannot factor into the single term, what's happened? There is such a case that its goals come down but goes up, it doesn't touch. Okay, and this case too. So do you remember in the quadratic function we have like come down but it doesn't touch, go back? And what kind of roots you have? There's no roots. So what happened is this kind of the function have the complex number root. So what we say previously, if we count complex number root, then the rules gonna change because it can go like that, and you have many minimax but the root is only 1, right? But here we count complex number as a roots, so this produces roots. So as long as we count roots, double is 2, triple is 3, complex number is also the roots, then roots number always exceed minimax. You get it? So that's another point we have to note. So shifting polynomial function. How do we shift polynomial function? Do you remember shifting? Y axis shifting plus b, right? X axis shifting is negative c inside x minus c. So x shifted by 2, the function look like it's moving toward this way, right? And y shifted, all the functions go up this way by 20. Okay, so this is like watching animation. The curve moves on the screen. Yeah. Okay, so we can shift. That means if the form is factors like that, then replace x with x minus c, right? So the characteristic doesn't change. The point here is shifting polynomial function doesn't change the characteristic. It's just like animation, entire curve move right, left, or up and down. But up and down, it may change because cross point may move. What's happened if you move this down to here? You used to have a 2 roots, but now it doesn't cross, so you have a 2 complex number roots. Remember, we count the complex number roots too. So it's changed from 2 real number roots to 2 complex number roots. Okay. We keep going. We're doing very well here. Inverse function. So this n to the third is going to go up and down here. On the way, it may cross 1, 2, 3 roots, right? And inverse function, remember, inverse function is the y equals f of x. I'd like you to review inverse function previous video, okay? The inverse function is a different function, okay? Inverse of, right? Because x equals gy, I'm sorry. Inverse function x equals fy. xy is swapped, right? And rewrite it into y equals form, then it's going to be different function. So this function is going to be let's see, 45 degree. That means it's like that. You flip it, so it's going to be like that, okay? This you're right, this is correct. Since you are crossing here, it should cross here, right? It's cross and come back and cross here. I think this is correct. Okay, so this is the way it's inversed. The scale, it looks exactly flipped, xy flipped, because the scale is also changed. So it looks correct. This is correct. Okay, so adding or subtracting polynomial function. So what's happened to add this polynomial function and this polynomial function? Both are added. Then this has x to the third. This has x to the second. So do you remember? This guy dominate. So when x is large or extremely negative, then it's dominate. That means this part is going to be here, right? And inside, between this range, is going to be modified by this guy. And instead of crossing here, it's cross here. But this part is going to be determined by this dominant ordered. So if you know the rule, you can create the graph. Now polynomial function with one root value. Let's see. This is the way use Pascal's pyramid for the expansion. Pascal pyramid is something maybe you should know. When you have this kind, you can expand into this, or you can factor from here to this. Okay, so here's the Pascal's rule. Rule is about this coefficient. What kind of coefficient do you get when you expand this? Okay, so suppose a is 1, this a is 1, then you start from this, you look at this, expand 1 to 1. What does this mean? X squared plus 2x plus 1, and you add this 1 to this 2 makes 3, same way. So when you expand, third, the coefficient is going to be x third plus 3b x second plus 3b squared x plus b third. Okay, this coefficient 3 and 3 can be determined by Pascal's triangle. What is the next order? 4. You expand it, you get 4, 6, 4. And next order, you can get it by adding here 5, 4, 6, 10, 4, 6, 10, 1, 4, 5. Okay, so now you know any number of any number n, when you expand, what is the coefficient? Xn plus coefficient a1 b n minus 1 x b n minus 1 plus a1 a2 b square x n minus 2, so and so. This coefficient a0, a1, a2, so and so can be determined by this Pascal's triangle. Okay, and that's a kind of trick for very special case polynomial you can use. Now polynomial function with one root value. Polynomial function with one root value. So this, I think we talked about this already. This is one root, but actually we count as a 3 roots, 3 identical number, 3 roots, right? And in this case, there is the complex number roots. Okay, we count that too. So general characteristic of polynomial function. So if we summarize all of that, we have a general form of polynomial here. So what we do is we look at the sign of an. Positive sign and n is even, then go this way. If negative sign and n is odd, it's go this way. If negative sign and n is even, go down again. And a is positive, but all the function go down again. Okay, if positive, then it goes up. It's negative, it goes down. And deciding factor is this most significant term of polynomial, the sign of a0, and whether this n is even or odd. You look at this, you can tell which way it goes. Okay, this kind of things I never see the description in the math textbooks. I think you learn only in this video, and it's good to know from my experience because you can tell what kind of function the polynomial is. Okay, so example to show the trend of function curves based on the rule above. You can tell -3, -a0, and odd number. So function goes up at the extreme negative, and the function goes down at the extreme positive. So why don't you practice the rule you learned minutes ago on the video and see if we can concur with this answer here. Okay, this skill become very important later when you deal with rational function, because there's a question on how to draw rational function on the xy coordinates, and without this it's almost impossible. And a lot of math book missing this part and ask you to do that task, and you can't, obviously. Then you get confused and you dislike math. But if you know this, math is very simple. Okay, so here's the practice. Factor the polynomial, obtain roots, and write them in order of smaller number. Okay, can you factor this? This is a factoring practice. It's just beyond a quadratic function, so they need a little bit more effort. Okay, try them all as a practice. Okay, so that's the end of basics of polynomial function in Algebra 2. The first things you learn in high school Algebra 2 is polynomial function. Okay, and you got a lot of stuff that you cannot find in textbook. You can look up the textbook, see if you can find those. You can't find it nowhere. Okay, I hope this helps you to study Algebra 2 in high school. Thanks for listening, and we meet you in the next lecture.